Alright, so hello and welcome. Howdy. I had an issue just a moment ago where, oh no, keep forget. I'm so annoyed, I don't know, I'm kind of distracted right now. My mind is all over the place. But, I'm already irritated. At the gate, irritated. That's alright. Okay. So it's a great way to start. I had already had to restart, so I don't restart again. It's a pain in the neck. You have to like end the stream, delete the video, start over again. We're not gonna do that. We're just gonna keep going. Yeah. I wouldn't say it's laziness. It's just it's not worth the frustration. Just keep trying over and over again here. But I wanted to. The reason is I wanted to listen to. So okay. So the beginning of the video would be here. I want to revisit UTF-8 validation on LeetCode's. I had solved this maybe 6 months ago. And let's just say I had a stroke of, we'll just say stroke of inspiration. I don't want to say where it came from, but a stroke of inspiration to go ahead and revisit this question. There's another way to solve this problem that I think is very clean, and I like it a lot. Well, the first time I had to approach this problem, it was not very clean, and it wasn't great. So yeah, it was really messy. It took me almost an hour, and like I said, it was just pretty messy. So I wanted to revisit this problem. We'll get into that in just a moment. I wanted to, before we get into that though, I wanted to say, oh yeah, I wanted to listen to music. That was actually why I was so frustrated, because I wanted to listen to music, but an ad started playing, and I forgot to put the audio down. So I had like a few seconds of just very loud ads at the beginning of the video. It's like, but yeah. Put in the background. Alright, so it's interesting, so we'll go over this in a second. We'll explain it. Hopefully this won't take too long. Okay. Give integer array data representing the data, return whether it is a valid UTF-8 encoding. Character in UTF-8 can be from 1 to 4 bytes long, subjected to the following rules. 1 byte character, the first bit is a 0, followed by its Unicode character. N bytes character, the first n bits are all 1s, the n plus 1 bit is 0, followed by n minus 1 bytes, with the most significant 2 bits being 1, 0. UTF-8 encoding would work. So like this isn't a very good explanation in my opinion. Let's just say recently someone explained what UTF-8 encoding is, and it was a much better explanation than this. I think that's probably why this got so many downvotes. Also, this is getting kind of loud. I wanted to listen to music, but it's kind of distracting, truthfully. Here's the deal. UTF-8 works like this. It could be the first bit is 0, and the next bit is first bit is 0, and that would make that a header byte, and that would be just regular ASCII, a regular ASCII byte. If there is a 1, 0, those first 2 bits, that's called a continuation byte. So that means that's going to be part of another UTF-8 encoded character. And then the UTF-8 encoding the header bit, the header byte, the number of bytes involved in that particular character is going to be equal to 1. It's going to be equal to the number of 1s that were set in that first byte. So your byte might have 8. You could have at most 8 1s straight across. That would mean you're going to have 7 more continuation bytes. So that way you would have 8 total bytes for that UTF-8 character. So you can encode a lot of characters doing it this way with UTF-8. So basically every character could have at most 8 bytes per character. And so now, so if you wanted to, so the deal is you can understand the header bytes. There basically would be, there really are the bytes in UTF-8 could be reorganized and understood as there are 8 types of bytes, 8 categories, where the, I'm sorry, yeah, I guess, yeah, no, that's fair. That's fair. Actually, no, I shouldn't say that. What you could say is every character has a header byte, and that header and possibly zero or more continuation bytes, and the header bytes are understood as it's the number of most significant digits, no, most significant bits, the number of consecutive most significant bits that are set to 1 tells you how many continuation bytes you expect. So if you see 1 0, there's no continuation byte. Excuse me, it's that value will be 1 more than the number of continuation bytes, or that value is the number of bytes in the whole character. So 1 0 would be just the header byte itself is the character byte. If you see, I'm sorry, excuse me. Actually, this is really confusing. I'm explaining it incorrectly, actually. I guess that's why it's hard to explain it. I mean, yeah, it's not the best explanation, but even I'm not giving a particularly good explanation. So, at the moment, so the first byte, if you see it starts with a 0, that's both the header byte. That's the only byte in the character. If you see a 1 0, that's not a header byte. That's a continuation byte, followed by anything else. And then if you see a sequence of 1s, and you know, it could be a 0, ends with a 0, or there could be no 0 at the end. That represents that means that header byte is a header byte, and it's going to be the number of 1s from left to right represents the number of bytes in the whole character. So if you see like 8 1s, that means that header byte is 1, and then there should be 7 continuation bytes following. Yeah. It's a little confusing, but I think that's why it's a good question to ask in an interview, because it's like this tricky little sort of, it's challenging to kind of understand and explain it. So you can write code to parse UTF-8 sequences, and that's what we're going to do now. So it took 7 minutes of explaining. So the deal is we want to write a routine that will validate if a sequence of, we'll call them integers. It could be really should be characters, but sequence of integers, if they are, if that represents a valid UTF-8 encoding, which means that, so if you see, so each header byte that you see, if it's 1 byte, so if it starts with a 0 bit, most significant bit on the left, then that's valid, right? And you can move to the next one. But if you see a continuation byte when you're expecting a header byte, that's invalid, right? But if you see a header byte with 2 or more first bits, most significant consecutive bits, 2 or more, that means that you're expecting to see 1 less than whatever that number was, number of continuation bytes, which we said before, continuation bytes starts with 1 0. So that's what we want to write. Our routine is to make sure that we each time that occurs, we see exactly that many number of continuation bytes. And there's a way to do this that's like pretty concise, and I like it. And I realized it at one point. I was like, oh hey, like this is a really good question to ask, but like there's a very concise way of doing this. So we're gonna do we're gonna say count significant bits, or lambda expression. We're gonna start with that because this is very useful, I think, for this. What we're doing would be very useful to count the number of bits. And we're gonna say const number of bits in an integer. So I'll call it x. And we're going to start with int mask. It's going to start off with, so we're going to bit shift 7 positions to the left, right? So it starts off in the first position. We want to add 7 positions over, so it's in the eighth position on the left side, right? And then we want to do the following. We're going to say I equals 0, I is less than 8. So 8 times, we want to perform our check. Increment I, and we're going to decrement the mask. We're going to bit shift it to the right. And we're going to do, now this is going to be kind of a subtle thing, so mask and x. If it's true, there's a return value that we want. We'll start off at 0. We're going to increment the return value. And And here, now this is another kind of a subtlety. We terminate early. So count the bits. Count the most significant bits from left to right, starting in the 8th position and terminating early when a 0 is found, terminating when the 0 set to 1. Yeah, so that's what's going to happen here. So we're gonna, if we don't have a 1 value in that position, then we don't have a 1 value in that position, then we terminate early. Then we're done. And once as soon as we see a 0, that's it. So we're counting the consecutive sequence of 1 bits from left to right until we see a 0, right? And then now we want to say check each header byte, and if that header byte implies more than 1 byte for a given UTF-8 character, then ensure that there are exactly the desired number of following continuation bytes to satisfy the format, or to satisfy the header byte, the number specified with the header byte. Something like this. It's kind of a lot of words, but something like that. So we're going to do I equals 0, I is less than data.size. We're going to say, and you actually want to use size t for a vector. And we're going to say constant b is going to be for a byte, it's data of I. And then we're going to say, now we want to use, so if, we're going to say count, we can do constant count. Yeah, that's fine. It's going to be count significant bits of b, right? So count the number of significant bits. And now we're going to say if the count of bits is 0, right? And this is a single header byte. The format is correct. So we just continue. If the count is 1, return false. Continuation byte when a header byte is expected. And the format is incorrect. And then finally, in all the other cases, it's greater than 1. Ensure exactly the correct number continuation bytes follow header byte. Now this is a subtle thing. We want to, so we're going to say, so if, it goes like this, if, then return false, and then otherwise, so we're going to do 2 checks, right? The first check is if there aren't enough bytes to process. So there could be, it would be something like, if there aren't enough bytes to process, that means that if I plus count is greater than data.size, or and this is going to be an interesting check. Yeah, so if there aren't enough bytes, if there aren't enough continuation bytes, so how do we get the number of, I guess we could say the total number of bytes has to be, so the total number of bytes, you can do it this way, it's an easier way to think about it. Total number of bytes, which is data.size, minus the number of bytes that you've considered so far, which is, and you say it would be less than count. So it's actually, if it's not possible to have enough bytes, and you would say data.size minus I, so it's data.size minus I is less than the count. Yeah, I think that's right. So if you had like 5 and 3, 5 minus 3 would give you 2. But I guess you'd have to add 1 to include. You could do it this way. Yeah, it's a little confusing, but if you have 5 minus I is all of the bytes you've already considered, plus 1 includes the header byte. If that's less than the count, which the count includes the header byte, then you would return false, right? It's not possible. You don't have enough continuation bytes, right? That's one thing. And then the other thing is you can do algorithm, make things a little bit easier. Oops, oh no. How do I keep doing that? I don't know. There's some like hotkey buttons that I just randomly press from time to time and end up on a window that I wasn't expecting to be on. It's kind of annoying. Yeah. So now what you want to check is all of the following should be true, and if it's not all of these, then you have an issue. And the all of, let me just double check that. Right. So you have to have an all of routine. Yeah. Find if not. So all of, right. So if it's not all of, we're going to say data.begin plus I to data.begin of I plus the count. And the routine is going to be very simple. Return, it's going to be const int x, return count sig bits of x equals 1, right? So there should be, so something like this, and then hold on 1 second. I is then going to update to the count, right? We're gonna add. It's actually count minus 1, and we're not going to include I in the header bit. So this is kind of an interesting thing too. We want to say that we have enough bytes to check. That's the first thing. And if you do have enough bytes to check, you need to make sure that all of the bytes are continuation bytes, which means that the number of significant bits is 1. So all of the bytes are continuation bytes, and if they're not all continuation bytes, return false. If they are all continuation bytes and you have enough, then that means you're going to move I to count forward count number of indices. Something you have to be, it's subtle here, you have to be careful about is, something subtle here, something to be careful about is that you don't want to move it too far, because this plus I is going to account every time for the header byte. You only want to increment for the continuation bytes. So yeah, very slight thing. Ensure that there are enough bytes to check, enough continuation bytes in the array. ensure that there are enough bytes in the array to check. Ensure also that there are all of the following bytes are continuation bytes if either of these cases fail, then the format is incorrect and we terminate early. I can check byte and there is exactly one consecutive most significant digit. That the sequence of consecutive most significant digits set to 1 is exactly 1, size 1. Something like that. Increment the index into the data, to the array. Pass the count continuation oh no by the outer loop. Yeah, so something like this. Oh, I didn't. And if we finish here. Okay. How are we doing on time? 22 minutes, 23 minutes. Okay. Fair enough. Oh, I need to capture this. Let's see, any other mistakes that I made? Hey, alright. I think this might be correct, just as it is. Like, it's pretty, this is like a very straightforward solution, I guess, but it's also, like, it's not the easiest thing to come up with on the spot, I suppose, if you had to. Yeah, I thought about this a little bit, had a few days to kind of ponder this. I'll just say, I mean, obviously I saw this 6 months ago, but this is like a much cleaner solution than the one that I had originally for this problem. The one I had originally for this problem was pretty good, pretty ugly. It's pretty gross solution. Let's see. Let's try some test cases, I guess. Yeah. Oops. Too many hotkeys, man. Too many things to. Let's try some random integers here. I think 8 bits. Actually, no, they'll have to be in between. I was gonna say that'll be 255. Yeah, it's too big. Okay. The last one almost certainly is false. What are some other? Okay. So what I want to do is try that one. You don't have enough bits. Try this one where you show twice, and then can we do one that? What is that? Three bytes. If we could do 3. 3 bytes would be 197. Okay, let's do one. What is it? It's think it's 128. 128 is a continuation byte. And then 197 is like 128 plus, what's that, 64? Gives you 188, 192. And then you want to add another 32, which gives you 192 plus 32 is 292 plus 20. No, 202 plus 22, which is 224. Right? Something like this. What does this give us? Does it give us true at the bottom? It does. I think it's correct. I don't know. We'll go for it. Let's see how it goes. No! Oh, of course. Really? Oof. Oof. I should have tested more things. Thought about it. I was thinking to test more things, but brutal. I had the opportunity too. What did we just do? I had the opportunity for redemption. The other thing it is, it's kind of a pain in the neck coming up with these test cases with the all the bits. You gotta like figure out how you're gonna get a string of ones and do all the calculations. It's just prone to laziness in that case. What happened? Really? All right, fair enough. I'm disappointed now. I thought I had this too. I thought I had it. Thought I was so smart. How do we get a runtime error here? 248, 130, 130, 130. So 130 is what? Let's try to do that in our head. So 128, yeah. So these are continuation bytes. These are 3 continuation bytes. 248 is. No, let's do it in our head. So it's. Yeah, it's a pain in the neck to actually convert that in your head because you have to do 8 divisions by 2 and then reverse the remainders. So you get 0 gives you 124. 0 gives you 162. 0, 0, 62. 0. So 0, 0, 0. You get 62. Or no. 0, 0. 62. 0 again gives you 31. 1 gives you this is 4. I is 0. 4 minus 1. This should have just returned false, no? What happened here? Did this not enter this loop? So no. I was trying to be clever and not use a raw loop and try to do this in a way that's very like concise. No. So do we even? I mean, we should get to this point, right? Check. Yeah. Why not? This is actually exactly the case that. Oh, I think I probably just did the math wrong here. How about that? I guess this is true. That must be the problem. Sorry. Zero. False. Oh. Yeah, this should be true, actually. Wait, what? That is the problem, but what? Data. Total bytes. I'm disappointed. Current index. Count. Okay, let's try this. Oh, that's disappointing. Yeah, that math is tricky, man. How do we get 5? That doesn't seem right. That's not true. X. Or B, excuse me. Oh, it is 5. Okay, excuse me. 1, 2, 3, 4, 5. Yeah, all right. If the data.size, which is 4, minus I, which is 0, plus 1. Oh. Are we not supposed to add 1 there? No, Oh. Aha. Or if it's not equal, if it's too many. Well, actually, wait. It's really both. Actually, in this case, it is equal. But it should. I think it's supposed to be this. How did? I think that's the problem. But also, well, being less than should be fine. I think I'm so confused. No, what is going on? I don't know. I'm so confused now. My brain is spinning. So, oh no. I'm sorry. I did that wrong. Yeah. I'm disappointed. That's such a tricky thing. It's such a tricky thing. The issue is the following, right? The issue is the following. You want I to whatever you want to, first you want to make sure there are enough bytes to do this. And the way to ensure that there are enough bytes is you want to take the total number of bytes, subtract the index. Now, the tricky thing about that is the number of bytes up to the point where you have the index. See, this is one of those things that's like really subtle but really tricky. Is that you take the total number minus an index. It's not quite the math on that is not quite what you think it'll be. It's because the total number of bytes, including that index, is actually the index plus 1. So it's the total number of bytes minus I minus 1. Right? It would be minus I plus 1, which would then be minus I minus 1. Right? Which is very subtle. But then if you want to include that byte in the section that you're looking at, like the total number of bytes that you want to count, if you don't want to remove the header byte, but you want to include the header byte, you have to add 1. That's why you get data minus I less than count, not data minus I plus 1 less than count, which is the part that I got confused. Is that in order to count numbers, you would take you had numbers b and a. You want to count the number of numbers between b and a, including b and a. You do b minus a plus 1. Because when you subtract a, you would subtract everything to the left, including a itself. However, the tricky thing with when you have an index which is 0 index versus a total count, which is 1 index, you have to account for the 1 index versus 0 index, which is something that always trips me up. I always forget it. I always struggle with that. But you have to be careful of something that's 0 indexed versus something that's 1 indexed. A total count is 1 indexed. An index is 0 indexed. So you have to subtract 1 from the total count or add 1 to the 0 index in order to get them lined up in the right in the right kind of universe, I guess, if you want to call it that, or the right world, the right alignment, I suppose. So that's why it's data size minus I rather than data size minus I plus 1. Yeah, I always mess that up, man. That's a really tricky thing. But it should be correct now, I think. We should be correct now. But yeah, this is a very like concise way of doing this. If it works, I hope it works. Hopefully we got all the test cases. No! Oh, come on. Oh, that's disappointing. You can see why I want to revisit this too. It's just like, come on, man. Now why? What happened? We got true, expected, false. Now I want to say this is supposed to be equal to. It should be not. This one should be not equal to. I have this very uncomfortable feeling that this is what I should have used, and not just less than, but it's not equal to. I was assuming that if it's. Oh no. Nope, that's not it. So what could it be? What could it be? Well, we expect false. So let's take the bit set of on each bit. Let's print that on each byte. Yeah, I guess this is not a very good way of doing this because this is very prone to error. It's really prone to error, which makes it a good question to ask, but very challenging, I suppose. I don't think when yeah, you can see why I want to revisit this. That's annoying. I did this right the first time, or not the first time, but way back when, 6 months ago. 6 months ago. Okay, so 1, 2, 3, 4, 5. We got that, and then what happened? We should have entered here. We did, and then we didn't return false. We made it through here. Now the question is why? Why did we had 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right, so this should return true, or yeah, it should be. This I think is false. If we check this, and then we'd have to check here. Yeah, but this all of wasn't true. Begin plus I is the first so this the first continuation byte. This is not going to be the this is going to be the byte after the header byte, right? The header byte would be begin plus I. Yeah, because I is an index, so it's going to just begin plus index. Add 1 to go to the next index, so it's got to be 1, 2, 3, 4. Now, when you add the count, what's interesting is, oh wait, this is false. Wait, what? 2, 3, 4, 5. I'm really confused now. What's 145? What? I actually would expect this to be true. Oh, you know what? This is why I got so many downvotes. I think the way that this problem is set up, they only want 4 bytes rather than 8 bytes long. Or UTF-8, I think it's supposed to be 8 bytes. And I think that's the problem, is that there's 5 bytes here, or five values here. This actually, the way that they had set this question up, this actually should be true. Oh man, that's a doozy. How about that for like frustrating and upsetting? Oh no, this actually is doing what it's supposed to do. 145 it has, yeah. If you oh no, really? Yeah, 145 is probably a continuation byte. Oh no. Yeah, it is. So this actually is correct. This actually is a correct UTF string. Oh, I see. Oh no. Oh no. Oh no. I see. Uh-oh. 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 Just have to make a small change for this particular question. Man, but this is pretty concise. This is, yeah, you gotta be really careful here. This part, you have to be careful, and this part. But this is all you need for the logic. Pretty good, but the problem is this particular problem. They're saying that, interesting, if the count is greater than 5 or so, okay, what do we do? So this one they said is false. 1 byte character, the first byte is a 0, followed by its Unicode character. N bytes character, the first n bits are all 1s. N plus 1 bit is 0, followed by n minus 1 bytes, with the most significant bits being 1, 0, followed by n minus 1 bytes. How the UTF-8 encoding would work. UTF-8 octet. 1, 2, 3, 4. So I think part of the issue is that if we have 5, if we have a count greater than 4, I guess, we just return false. Maybe that's what we can do. Note that for this particular question, if the encoding count is greater than 4, we must return false. UTF-8. He does so. How many bytes in UTF-8? One to 4. Oh, that's interesting. But you can only use 4 at most. Oh, interesting. I didn't realize that. Whoops. So I'm not wrong, actually. Oopsies. Whoopsies. What is it? I'm wrong. I'm not wrong. What was I saying? Excuse me. I am under the wrong impression that actually no, this was correct. The something else was wrong. Let's say something else was wrong. Whoops. whoopsies. We missed something. We missed something. UTF-8 is only supposed to be 1 to 4. Why did this get so many downvotes? This is such a good question. Uh-oh. Uh-oh. It's 1 to 4, 1 by... Oh, okay. Ooh, that's awkward. Count is greater than 4. The UTF encoding is invalid. That's a slight detail. That's an important, subtle, and slight detail, and I actually missed that detail in the past. There we go. Actually, I kind of like the first solution I wrote to this then. The first, how long did this take? 45 minutes? No, this is pretty quick. It was pretty concise. I like this, you know, I think this is okay. The first time I solved this problem way back when, 6 months ago, we actually looked at that video. It was pretty messy. It did take me like an hour. I don't know, man. This is kind of hard. Like this approach is good, but it's pretty challenging to get it right, in my opinion. Like it's pretty challenging to get all these pieces in the right spots. 15 milliseconds. Oh, really? Oh, wow. When I first wrote this, these were like pretty fast. I think it was like 97% or something like that. What was the? Where is? Let's go to my videos. Let's do that. This is interesting, man. Huh. Let me see something here. Browsing the web while streaming is like, especially because I'm streaming from a laptop. Especially because I'm streaming from a laptop. I'm looking for, yeah, somewhere here. I was just looking at this the other day. Yeah, here we go. All right. Interesting. So actually, this is wrong. What I'd done. So yeah, so this was really, this was super messy previously when I did this the first time. I solved it relatively quickly, but it was ugly. He used recursion. I used recursion, and I used an unordered map. I memoized a recursive routine. Because I think I just wanted to solve it like really quickly. I don't know. It's just, I don't know what I was thinking at the time, but yeah, this is what I ended up with. This code, like, but it was actually, this is actually correct. This problem, this is correct. Also, the solution was fast when I did it. Solved it way back then, way back when. I ran into some issues though. Oh no, I'm sorry, it wasn't that fast. I take it back. Never mind. Interesting. So my solution now seems to be a little bit faster, but no, it's kind of slow. It's kind of slow. But yeah, I did solve it way back when. And I guess, yeah, I was wrong. I was wrong. The number of bits, you can change this routine to be a lot faster. I think you could use masks for the significant bits. So you could say, to do this really quickly, you can say like, well, no, I guess not. No, that's probably as fast as it goes. Actually, I don't know. We'll leave it. It's okay. We don't need to get too crazy. But yeah, the logic is really straightforward if you do it this way. I think I did it really poorly the first time around. And then I missed this part though. There's like two cases I missed. And let's just say there was, yeah, okay. You could change this. As well. How about that? Add one less branch. Hey, that's pretty quick. That's relatively quick. I think, apparently there's a way to do this even faster. I like this. This is okay. This is like pretty clean code. It's pretty efficient. Don't actually need this here. You can make it faster as well here. Oops. Just thinking of ways to make this faster. One, two, three. No. Okay. All right. I think we ended here. Yeah, 50 minutes. Okay. Last time it was like an hour as well. Yeah, I have a few things to. It's good that I rewrote this because I thought about it and I was like, you could probably do it this way, but part of the problem is like you need to get the indices correct, which I did. I didn't get them the first time when I wrote this. It's a good thing we actually wrote it because that's a very subtle thing that throws me off often. And then this part I did right though. That was fine. Yeah, okay. And then also with UTF-8 encoding, you gotta be careful. It's not 8 digits. It's 4 4 bytes. It's only 4 bytes. If you go more than 4 bytes, it's incorrect. It's good to remember that. Yeah. So I have solved this problem before. I've solved this problem. Yeah. Okay. 12 milliseconds. Okay. 12 milliseconds is only. It's not the fastest. So apparently you can make this even faster. So these two cases you just return false immediately, and then in this case, do you need a branch for this though? I guess you'd say if it's less than or equal to 1. No, well you wouldn't return. You would continue. Yeah. Okay. I get it. No, that's fair. Can you put no else? If it's not equal to 1 and it's not greater than 4, right? Then you can go to this branch as long as it's greater than 1, less than 4. There's probably a way to logically handle this where you don't need 2 branches. That probably is how you speed it up to get like 100%. Maybe you can say, I don't know, how would you do this? Yeah, that's pretty much it. That's pretty much it. I don't know. That's probably good enough for all intents and purposes. So yeah, it was nice to revisit this problem though. I think there's a much cleaner way of doing it. Yeah. kind of disappointed myself though for the times that I've tried to solve this problem, and it wasn't very clean, wasn't very good. All right, I'm gonna go. So thank you for watching. Talk to you soon. I'm gonna go ahead and I think I'm gonna take a break for a while. I kind of was what was I saying? I was kind of take a break for a while. I was kind of I don't know, my mind's been kind of all over the place. Like I feel kind of bad like not spending enough time like practicing, you know. I don't know. I suppose it's okay. All right, I'm gonna go. Thank you for watching. Talk to you soon.